Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining spanning tree protocol. As we saw in our previous video, layer 2 loops can be devastating for any network. One way to resolve layer 2 loops is to physically arrange the connections of your switches in such a way so that no layer 2 loops can form. To do that for this topology here, we would physically remove these links here to get this. But this has its drawbacks, and it is definitely not best practice for any network requiring any level of redundancy and high availability. Indeed, it would be great if you can connect all your switches with physical layer 2 loops like this, but have some mechanism that will automatically, dynamically, and logically block specific ports so that the result is the logical elimination of any layer 2 loops. And then, if something fails, those blocked ports can be automatically unblocked and will continue to function, thus resulting in redundancy. Well, that's exactly what spanning tree protocol does, and it's an ingenious way to resolve layer 2 loops. So what does spanning tree mean? It's kind of a strange name. For us network engineers, beyond the protocol itself, the term spanning tree really doesn't mean anything. That's because spanning tree comes from a different discipline. It comes from the mathematical field of graph theory, which is the study of graphs. Now, when we talk about graphs, we're not talking about something like this. We're talking about something like this. This here is a graph. The term graph in this context is a mathematical structure used to model relations between objects. A graph is a construct made of vertices and edges. These here are the vertices, and these here are the edges. Does this diagram look somewhat familiar? It can look like a network where the vertices are devices such as routers or switches, and the edges are links between them. Because networks can be represented very well by mathematical graphs, many networking protocols use graphing theory to a great extent in their operation. Routing protocols, as well as layer 2 protocols, such as STP, use these mathematical graphs and graph theory to operate correctly. In the context of graph theory, a spanning tree is a subset of a connected graph's edges that connects to all the vertices without forming any cycles. In plain language, what that means is if we have a graph like this, a spanning tree of this graph is this one here. Note that all the vertices are still connected by at least one edge, but we have eliminated certain edges so that there are no cycles or loops. Now imagine this is a network and these are switches. The STP protocol will allow the switches to communicate and decide amongst themselves which ports will be placed into a logical blocked state so that a spanning tree is formed. Now, in order for an edge or a link to be considered blocked, it needs to be blocked only on one side or one end of the physical link. So you don't need to block both ends or both ports connected to that link. That's fundamentally what STP does. It dynamically and automatically blocks ports to ensure that a spanning tree is created within the grid or within the interconnected switches. And that spanning tree, by definition, has no loops. Now, the benefit here for a topology like this one is that we can achieve a spanning tree by blocking these ports here. The result is a logical spanning tree. Now, this doesn't mean that these blocked links are useless, because if this link fails here, the switches will communicate with each other using the STP protocol, and it will result in this port transitioning to the forwarding state, so that communication will be restored. That process is called reconvergence of the spanning tree. Now remember that any such topology will have multiple VLANs, and different VLANs will extend to different parts of the network, as some are allowed on some trunks while they're not allowed on others. This means that each VLAN has its own logical topology across the physical topology like this one. For this reason, STP creates a separate spanning tree for each VLAN. So you may have VLAN 10 on this topology with these ports blocked, while VLAN 20 may have these ports blocked. And this introduces another best practice, which is to try to influence STP so that for some VLANs, one particular path is blocked, while for other VLANs, a different path is blocked. That way, links don't remain idle, but are used efficiently. Now, it's important to note that there are several aspects about STP that must be kept in mind. First of all, STP is a standardized protocol in the sense that it is open and available for use by any vendor. Since its inception, there have been different versions of the protocol with various improvements upon how it works, improving convergence and reconvergence times, as well as scalability and VLAN awareness. The original version is defined by IEEE 802.1d and is known simply as STP, or Spanning Tree Protocol. Rapid STP, or RSTP, was developed later on, which improved upon the convergence speed, thus the name Rapid. And then Multiple STP, or MSTP, which is also sometimes abbreviated to MTP, was developed, which improved upon how multiple VLANs are handled by the protocol. The various versions correspond to specific IEEE standards, as you can see. Now, one thing that does get confusing, especially for Cisco devices, is that Cisco uses what is known as the Per VLAN Spanning Tree Plus, or the PVST Plus, as well as the Rapid PVST Plus protocol. These are Cisco proprietary protocols which were actually created and developed before the IEEE standards. In essence, however, RPVST Plus is Cisco's per VLAN version of RSTP, and it is compatible with RSTP. So it's simply another term to refer to RSTP, but on a per VLAN basis. And it's fully compatible with RSTP on switches from other vendors. Now, the truth is that the naming of these protocols and their versions has become confusing. Let me try to make it simpler and clearer. In virtually all modern switches, classic IEEE 802.1d STP is no longer the default spanning tree behavior. Indeed, in some platforms, it cannot be implemented on new switches, like Cisco switches. On my switch on my own network here, you can see that the options for STP are multiple spanning tree, per VLAN spanning tree, and rapid per VLAN spanning tree. Now, this introduces a new point of confusion. First, you can see that the multiple spanning tree is referred to here as MST, where the official name is MSTP, so keep that in mind. The other thing is that for both PVST and RPVST, there's no plus here, even though it is indeed the PVST Plus and the RPVST Plus protocols that are being referenced here. So we assume that that plus is used because the PVST protocol has actually been deprecated and it's no longer in use. Now, in most Cisco switches, the default mode is Rapid PVST Plus, which, as I said before, is essentially the use of RSTP, maintaining a separate spanning tree instance per each VLAN. So on all modern networks, you will use either PVST Plus on Cisco devices, RSTP, which on Cisco devices is RPVST Plus, or MSTP. But remember, all of these protocols do exactly the same thing. They create a spanning tree on a VLAN by blocking certain ports, resulting in a loop-free topology. It's just that they perform the function in different ways so that it'll be performed faster, more efficiently, and in a more scalable manner. Now, in order for a topology like this one to be able to implement the blocking of particular ports to achieve a spanning tree, there are several things that have to happen. All switches participating in spanning tree will begin to exchange what are known as Bridge Protocol Data Units, or BPDUs. These are the control plane messages exchanged between switches to build the spanning tree. Now, all STP versions use BPDUs, but their contents may differ based on the version being used. The exchange of BPDUs is at the heart of the operation of STP. To create a spanning tree in a topology, a root bridge must be chosen initially. This is essentially a single switch in the topology that will be used as the root of the spanning tree. It's referred to as a root bridge, but keep in mind that it is referring to a switch. It is from this root bridge that the protocol will begin as the point of reference and work its way outwards, indicating which ports will be blocked, resulting in the logical spanning tree. Now, as I mentioned before, for small networks, you really don't have to worry about any STP configurations. But for larger networks, the appropriate STP parameters should be employed to ensure efficient network operation for STP. Well, that's it for our introductory video on STP. If you like my teaching style so far and these are topics that you're interested in, check out my Mastering VLANs and Trunking course on my website. It goes into much more detail than this YouTube playlist and includes labs, configurations, PDF notes, quizzes, and a final exam, all of which will help you to master the concept of Layer 2 switching. Check it out now at my website. You can click on the link in the description below. More courses on additional topics are coming soon. Check it out and join my newsletter as well to be the first to know about new content, along with some exclusive offers along the way. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.